All right, welcome. Today, we're going to talk about one of the most powerful tools in all of science. And no, it's not some giant supercomputer or crazy telescope. It's a chart. But believe me, this isn't just any chart. It's basically the architect's blueprint for, well, for everything. The air you're breathing, the device you're watching this on, the stars in the sky, it's all in there. So let's dive in and take a look at the plans.
I mean, just think about that for a second. What if you had a cheat sheet for the entire universe? A single page that lets you understand the fundamental building blocks of reality and, get this, even predict how they're going to act. Well, that's exactly what the periodic table is. It's the ultimate guide to, the elements that make up everything. Okay, so at its heart, the periodic table is this master list of all the basic ingredients that make up our world. But here's the magic. It's not just a random list. Nope. The way it's arranged is pure genius. It lets us understand and even predict what each element is like, just by knowing its address on the chart. It's incredible.
So who was the architect of this masterpiece? A guy named Dmitri Mendeleev. Way back in 1869, he was arranging the elements they knew about, and he started noticing something, a pattern. Their properties kept repeating. But here's the truly brilliant part, the key insight that changed everything. He was so sure about his pattern that he actually left gaps in his table for elements that hadn't even been discovered yet. How gutsy is that? And what's wild is he was totally right. Eventually, scientists found those missing elements, and they fit into his gaps perfectly. Mind-blowing. Okay, so how in the world do we actually read this cosmic blueprint? Well, it's all about the layout. The rows and columns aren't just thrown together randomly. Oh no, they follow a very specific set of rules. And these rules tell a story about every single element on there.
Let's break this down. It's actually pretty simple. First, you've got the vertical columns. We call those groups. And the easiest way to think of them is like families. Every element in the same group has super similar properties. And that's because they all have the same number of electrons in their outer shell. Then you have the horizontal rows, and those are called periods. The period number is a dead giveaway. It tells you exactly how many electron shells an element has. Simple as that. Let's take a quick example. See period 2 right there? Every single element in that row, I mean everyone, from lithium all the way over to neon, has exactly 2 electron shells. 2, that's it. This simple, elegant rule works all the way down the table, and it's what makes this whole thing so incredibly powerful. All right, so we've got the floor plan down. Now it's time to check out the actual building materials. The elements themselves are basically sorted into 3 main categories, and trust me, each one has its own unique personality. So, over on the left and in the middle, you've got the metals. You know them, they're shiny, they're great at conducting electricity, and you can bend them and shape them. Then, way over on the right side, you find the nonmetals. These guys are kind of the opposite, often dull, terrible conductors. And then, walking this cool zigzag line right between them are the metalloids, like silicon. They're a little bit of both. It just shows you, again, how perfectly organized this whole thing is. Okay, now for the really fun part. Let's zoom in and actually visit a few of the most famous neighborhoods on the table. And first up, we're heading to the most energetic, most reactive block of them all, Group 1, the alkali metals. Man, these elements are the life of the party, maybe a little too much so. They are just wildly reactive, especially with water. In fact, you have to store them in oil just to stop them from freaking out and reacting with the moisture in the air. And get this, they're so soft you could literally cut them with a butter knife. And you've definitely heard of these guys. You've got lithium in your batteries, you've got sodium and potassium, which are totally essential for our bodies to work. Yep, these are some of the most famous members of that super reactive Group 1 family. Okay, let's do a complete 180. We're going to jump all the way across the table to meet another really intense family, the non-metals, hanging out in Group 7, aka the halogens. Now, just like the alkali metals, the halogens are super reactive, but in a completely different way. These are nonmetals. They can be pretty toxic, and they absolutely love to react with metals to form salts. In fact, remember sodium from Group 1? Well, when it gets together with chlorine from this group, they make sodium chloride. You probably know it better as table salt. Pretty cool, right? And yeah, just like before, you'll totally recognize these names. Fluorine, that's in your toothpaste, protecting your teeth. Chlorine, that's what keeps swimming pools clean. So these elements are incredibly useful. But man, you've got to respect just how reactive they are.
Oh, okay, after all that intense reactivity, let's go visit the calmest, most chilled out neighborhood on the entire table. Welcome to the far right, Group 0, home of the cool, calm, and collected noble gases. So what makes them so, well, noble and unreactive? It all comes back to their electrons. You see, unlike the other groups we've met, their outer electron shells are completely full. They're happy. They don't need to bond or react with anyone else to feel stable. They're already perfect all by themselves. That's why they're so safe and ideal for things like filling up party balloons or making those awesome, colorful neon signs. And of course, you know these guys. You got helium, right? Makes balloons float, makes your voice all squeaky. And neon, the one that gives us those iconic glowing signs. These are the true celebrities of Group 0, famous for just being stable and, keeping to themselves. Okay, so we've toured the floor plan, we've met some of the residents. You now have the basic tools to read this incredible guide to the universe. So how about we put it all together? You think you're ready for a quick knowledge check? Let's find out. So let's do a super quick summary. The periodic table, it organizes all the elements. Those rows going across, they're periods. The columns going down, those are groups. Remember, elements in this same group are like family. They behave in similar ways. And finally, everything is classed as a metal, a nonmetal, or a metalloid. Got it? Those are the fundamentals. Let's see what you remember.
All right, first question for you. The vertical columns in the periodic table, the ones that act like families, what are they called? Think about it, lock in your answer.
Okay, next one. True or false? Elements in the same group have similar properties. Is that true or is that false? And for the last one, think back to that super chill neighborhood on the far right of the table. Group 0 elements, like helium, what's their main characteristic? They are very what? All right, let's check the answers. The vertical columns are called groups. Next, is it true that elements in the same group have similar properties? Yes, that is absolutely true. And finally, Group 0 elements are famous for being very unreactive. So how'd you do? Did you get them all right? So there you have it. You now have the key to unlocking the secrets of pretty much everything. The periodic table isn't just some boring chart on a wall. It's a map. It's a guide to the universe. And every single little box on it is a new world with its own amazing story. The only question